We do have a special treat. David Rogers has agreed to join us remotely. David's located in the UK. I don't know if you can hear me, but
yeah.
Great. Thanks, David, for joining. Thanks for your flexibility on the timing as well. David is a mobile telecoms and security specialist. He runs Copper Horse in the UK. It's a software and security company based in Windsor, and they're currently focusing on research for AI model security, product security for the Internet of Things, as well as future automotive cybersecurity. David chaired the fraud and security group at the GSMA until March of this year. He's authored the UK's Code of Practice for Consumer IoT Security in collaboration with the UK government and industry colleagues, and has served on the UK's Telecom Supply Chain Diversification Advisory Council. From 2015 to 2022, he sat on the executive board of the Internet of Things Security Foundation, and he's worked in the mobile industry for over 25 years in security and engineering roles. Prior to this, he worked in the semiconductor industry. David holds a Master's of Science in Software Engineering from the University of Oxford and an NHD, which I don't know what that is, but it sounds impressive, it must be a British thing, from mechanitronics from the University of Teesside. He's lectured in the mobile systems security at Oxford from 2012 to 19 and served as a visiting professor in cybersecurity and digital forensics at York St. John University. He was also awarded the MBE for services to cybersecurity in the Queen's Birthday Honors in 2019. More importantly, David is a really great guy. I've gotten to know him over the years through the GSMA Fraud and Security Group. He's very passionate about security and promoting security in the telecom industry. And he's a great speaker and lecturer, and I'm sure I'm going to learn a lot today. And I hope everybody enjoys it. So again, David, thanks for joining us.
Thanks, Tom. That's very kind. I'll talk to you about HNDs another day, but yeah. Yeah, thanks for inviting me. It's really a great honor to be here today. I decided that I wanted to talk to you about what the future looks like for mobile networks. It's going to be very different. I don't necessarily agree with the trajectory, but I think you'll find it interesting, and it might spark some thoughts and questions from you. So please be ready for those at the end if you want to ask me anything. So without further ado, I shall continue. Can you see my slides okay, guys?
Yes, it's great.
Okay, so the title of my talk is Virtual Insanity: The Future of Mobile Networks and Humanity. It's quite a big one, but it is a big topic, and the responsibility that we have as an industry is growing and growing as we connect every single object and every single person on the planet. If we look back to the start of the digital mobile world, so in the early 1980s, we could really probably never have envisaged the world that we live in today and the world that we're entering. I don't think most of those people, some of whom are still working in the mobile industry, by the way, I don't think many of those people would have realized that 2G networks would still be active today and still be relied upon in critical industries for things like smart meters and so on. But the success of GSM and the backwards compatibility function of all subsequent generations means that 5G standalone, a connection can be bidded down to a 2G connection and brought up to a 5G standalone connection. And that's one of the, I guess, powerful features of it, because it increases coverage, and it means that when you're traveling around, it doesn't matter necessarily what generation a mobile network is on. You will always stay connected. You might not necessarily have a very fast internet connection, but you would always, for example, be able to get an SMS messages. And this is quite powerful in terms of other connectivity as well. So if you think about IoT devices, and many billions of IoT devices now, if we install them, we can expect that they will continue to work for some time. So mobility is stretched to every single sector of society. Every type of thing that you can do with a mobile phone, whether it be gaming through to banking, any possible thing that you can think of can now be done on a smartphone. And that our entire lives are built around smartphones, for good and for bad. But also then if you stretch that into the business space, every single business sector, every industry in the world is connected to the mobile network. And then when you step back from that, it gets a little bit scary when you start to think about how we secure that and the many different types of threat actors and the many people who want to harm that for whatever reason, whether they want to commit fraud or target individual users, or right up to a nation state level where they want to target another country or another country's industries. We're now in a multi-access network generation, so we now start to see mobile devices that can, in one way or another, actually have access to satellites as well, and we're going to see more of that in the future. So the threat landscape that we're in, as I said, we have billions of IoT devices. We also have billions of consumers across the world. And in theory, an attacker can target somebody in Zambia from Thailand or from the UK or from the US. There's no geographic limits really to those attacks. And that's also another scary aspect. So if you think of every single way that somebody can be defrauded, we can come up with a way that you can do that enabled in some way by mobile. And then again, every single threat actor, so from an individual that is annoyed with somebody else through to a country, that everything the mobile industry has to defend against. So if I just look at some recent attacks and some recent things that have been happening in the mobile industry, so you'll all have heard about spyware, individuals being targeted by private companies who've developed and hacked their way into devices. And there's a cat and mouse game going on between those spyware vendors, and then when their tools are discovered, and then the patching by the vendors such as Google and Apple. But it's a pretty nefarious business, and they rely on vulnerabilities both in the handsets and in the mobile network itself. And so part of that problem is because of the legacy that we carry from 2G. So some of those features can't be updated, or they were never envisaged to be a security threat. And that has resulted in other types of attack that are still active today. So SMS-based attacks, SIM boxes, SMS blasters, which are a frequent thing now. And these, in the case of SMS blasters, they're relying on the 2G authentication, which was not mutual. So the handset didn't require the network to say, I'm valid. From 3G, that was the case. So many attacks will rely on that bidding down ability to go back down to 2G to do something nefarious and then allow it to bring up. And so those unsolicited messages that through SMS blasters that are being driven around on bikes in various cities are a real problem because they're difficult to stop, but they're on older generations of network. So many mobile networks are starting to turn down 2G and 3G now, and that means they're turning them off to free up spectrum for future generations. And so then we come to a sort of natural end to some of the abuse that we see, not completely, But it is true that many countries will continue to have legacy 2G networks well into the 2030s. And also, at some point, 4G LTE will become legacy and we'll see new future attacks that we've never seen before. So it's a unique element to mobility that we will always be carrying this legacy, and we need to think about how we solve that for the future. So on top of that, and with a rising tide of crime and newer techniques such as ransomware or large-scale data breaches or targeting by nation states in the case of Salt Typhoon or organized crime, we're going backwards as an industry in terms of the mobile network operators. So we're losing a huge amount of expertise. So for that legacy element, many people are retiring, some people are dying, and we're losing a lot of skills from the early 1980s that we still need. But in the structure of those companies as well, the mobile operators have moved away from largely having, lots of engineers who are involved in the standards bodies and know very much how a mobile network works, to something that looks a bit more like the car industry now, where they're heavily reliant on a lower tier beneath them. So the tier one vendors in the car industry, the likes of Bosch and so on, they essentially dictate what goes on in terms of vehicle components. And we're seeing that in the mobile networks now, in that the vendors really dictate what happens, and they provide actually services for managing the network and running the network so that mobile operators can concentrate on the business end of selling subscriptions, but the actual technical part is taken away from them. That's actually quite dangerous, because if you don't know how your business operates, it's very difficult to defend that business, and you can't entirely rely on the vendors. If we add to that the virtualization of mobile network elements, or softwareization into the cloud, it really takes away the control of the network from the mobile network operator. And in terms of innovation as well and growth, that growth goes to the cloud hyperscalers and to the vendors and not to the network operators. So I look at these things obviously through a security lens. And when I try to talk to the operators and I talk to the senior directors of these companies, they can no longer rely on their internal people to fix even the basic things. And so the situation that we're realistically in is that mobile networks have far too many holes. So this is a famous risk management illustration of this called the Swiss cheese model, which is where when all of the holes line up, then that results in some kind of failure. In this case, it starts with maybe a phishing message against the corporate IT user. Then there happens to be a default password on some network equipment that no one's changed and an unpatched vulnerability. Then the signaling firewall's not configured properly, and ultimately it results in a core network breach. I could do this model against other types of attack. The famous one recently has been against SK Telecom, where an attacker breached many different things, including femtocells, and basically in the end got the keys for SIM cards. There are many examples of this. So what we want to do, and I'm illustrating legacy here, by the way, that a legacy appears everywhere. This is a hotel that I was visiting, where they have the servant bells on the wall, still installed, maybe not in use, but it's still there, and legacy will always exist. But what we're doing here is we're essentially acquiring security debt. So a lot of people know what technical debt is, and what we're acquiring here is security debt. By not addressing the basic flaws or not removing things that are an issue, you are going to pay for it later on, either through a breach or through severe maintenance costs to deal with the problem and patching and so on, paying for software updates. Now, one route out of that is the work that I've been doing for years in the GSMA. There's some very, very good recommendations there. There's something called the Baseline Security Controls, FS31. But they provide the menu of tools and the menu of guidance that give you the path to fixing all of this. And actually, many of those issues can be dealt with internally. They don't require lots of tools that cost lots of money. A lot of it's down to configuration or stopping, protocols being used or so on. And it's about good engineering. So really just getting the basics right. When we still got network equipment with, I don't know, admin username as Huawei and then the password as Huawei, we've got really serious issues in this industry, or Nokia. Then we've got to think about the future. So if we know that this situation exists, and we know that we've got a problem with legacy networks and in the way that they're managed, how can we rely on 6G if we know that, for example, we can bid down to an earlier version of network and attack it, and that 6G will be backwards compatible? So it's a big risk. And it's a risk that I think the industry shouldn't take. I think we should have a logical clean break for legacy networks and with the past for 6G. And when I say that, I don't say it lightly, because many of the vendors would say, well, they don't want to do that for lots of reasons. But one of which is, obviously, they're not going to get 100% of users onto 6G immediately. So it'll be a sort of transition path. So they need that ability for a handset to be able to drop down to another network that's working. So I accept that. But if we acknowledge that this is a problem, that the legacy is a problem, perhaps we can find a way, and this is why I say a logical clean break, we could potentially find a way that if the handset or the device drops down to an earlier network, that any data and any traffic through that older network is very highly interrogated, and we essentially operate a zero trust environment for any legacy connection to kind of wrap those newer networks and the newer devices in cotton wool to protect them from attacks against older networks. And I think that might be a way out. It is being discussed at 3GPP at the moment, and I'm hoping that we'll get that into the design of security in 6G as a core principle. So let's assume now that we've secured everything in a mobile network and everything's okay. And we see this sometimes, there's some very good secure networks, and we're doing quite well in some places. But we as humans are always the weakest link. And that's why we're being more heavily targeted now, particularly where technical measures against fraud, for example, have worked. The criminals will target the user because they're the authorized entity. They have to have access to that technology. And so they're the key to the door for the attackers by many different ways, whether manipulating them in different ways through social engineering, dark patterns, heavily automated phishing attempts and so on. But I would say that the sophistication of attacks against users and a very clear end goal for attackers means that we really need to look at ways to protect users from this kind of a vector of attack. And what that means potentially is that we have other lines of defense. So if you've got an Android handset, for example, you'll see that it will now filter out many of the suspicious and spam messages and suspicious phishing messages before it even gets to you. And the same for inbound callers as well. And there's that sort of technique that we'll need to protect us. And this leads me really nicely to what's happening with AI. So we've created this world in the past couple of years where everything is generated by a large language model, by generative AI. Now, slop is the term that you'll see used. It means low quality imagery and content. You know, it's a good metaphor for what's happening here. It's different to hallucinating, where an LLM will generate something that's factually incorrect. But this we've created this environment where the human again is being harmed in a different way here, and the combinatory effects of targeting and you know, just pumping and dumping this rubbish, but still targeting the user is potentially very dangerous. So what we've got, and a good example of that would be maybe propaganda, where people just don't know what to believe. They kind of sort of maybe know that it's AI generated, but not in all cases. There are lots of issues here, like the videos on the right, they're being pumped onto YouTube Kids and other video platforms, and they're causing psychological harm to very young children. So in the general population, the reputation of AI is at a very low level, unfortunately, because there are some quite positive things that AI can bring. It's not just the sort of content side of it as well, it's the interaction side. So what's happening now is that we're seeing many people using things like ChatGPT as almost like a counselor. And the problem with these LLMs is that they affirm the user's input often. So they'll affirm their worldview. So in the case of marriages, when somebody's complaining about their partner, the LLM will affirm that worldview back to them, and not counter their view, and that's causing real world effects in terms of breaking up relationships. It's got really a lot worse in terms of LLMs that have been encouraging people to kill themselves. There have been many articles recently. There was a good one on CNN the other day. There are multiple lawsuits now against OpenAI because there are chat logs where the LLM is openly encouraging them to take their own lives and not provide that assistance. So this whole chatbot culture is creating real human harm, and people are dying. You know, this is a real problem. So we take the mess that's been created in the large language model world of non-deterministic outputs, of not being able to understand context and causing human harm to the individual. And then companies are suggesting that we use that for orchestrating the management of big systems like industrials or mobile telecoms or home IoT. And that really scares me. So what they plan to do in this world is they have autonomous agents that look after maybe one part of the system. So imagine maybe a part of a mobile network or a motor in a factory. And then the LLM interacts with those agents, and then they interact with each other, and they essentially manage the system together and learn the system and learn what normal looks like. But what happens when a mistake is made? Who's to blame? When we've been testing these LLMs, we have to approach security testing in a very different way into which we would know normally. So we approach it in a probabilistic way. So we maybe run 1,000 tests, and 98% of them give the right outcome. In a normal test, we would have a yes or no answer. We would run one test and say, is it on, is it off? And actually, in a safety-based, safety-critical system, that's exactly what you want, is deterministic behavior. But LLMs are non-deterministic. They're creative. Generative AI is creative. So there is always the potential, even with guardrails in place, that a command is generated or some kind of instruction that is non-deterministic and that causes the system to go wrong or to be damaged in some way or to cause human harm. That for me is not a tolerable scenario, and it feels like we're in the middle of being experimented on by some of these companies that will potentially never take legal liability for the outcome of whatever happens. So you could have seen in there that I said about running a telco network, and this is happening right now. Now, if you look at the press releases and the things that have been made public by these companies, there's a good one from China Mobile, for example, that says they saved $7 billion working together with Nokia on using LLMs within their mobile network. And they used it for O&M, for operations and maintenance, and for workflow optimization. Now, I don't know whether that $7 billion number comes from. Maybe it comes from the number of people's jobs that they cut and the salaries, but it seems quite optimistic to me. What I've directly seen and what I've heard reported is that often the LLMs generate other work where corrections need to be made. But these are also not being used to directly run the network. Then we're not seeing autonomous, the level 5 that you see on that TM Forum picture there. That's not happening yet, but we are seeing companies running towards that. Many mobile operators are looking at telco LLM orchestration. If you think that the mobile network's fully virtualized, so it's all software, so being able to scale up and scale down and manage with another piece of software is a relatively straightforward step. But whether we do that with an LLM is a big risk, I think. So, but that's what they're looking at, is having all these multiple agents to manage the network. Just yesterday, I saw that RAN Guardian has been launched, which is agentic AI, and that is being used together with Deutsche Telekom and Google to look at anomalies on the edge of the network. So it's happening now. It's being deployed now, and hopefully, at a smaller scale, they'll learn some lessons from this. But yeah, it's one other factor here that my colleague mentioned is in a crazy way, we don't actually understand fully how LLMs work. So that the benefit, the beauty of AI is that we're learning all the time, and these large neural networks are learning, but they're potentially beginning to speak in their own languages and so on. And we don't fully understand what's going on, and that's really scary. We, even in our own work, have noticed situations where the LLM creates some very odd output that is really unbelievable, and we can't understand how it got into that situation. And that's the same for everybody who's using this technology. So I don't want to leave this on a complete negative. We are where we are, partly also because the systems haven't been designed in a robust way. So many of the LLMs are trained on stolen data or bad data, poor quality data, and that training data can lead to poor outcomes. Plus, most of these AI systems are very vulnerable to modification because there's no integrity protection of the insides of them or the data sources that they take them from. So if we're truly to secure AI models that we want to rely upon, and not just LLMs, but things like, we're working on convolutional neural networks for embedded systems, for example, for reading street signs in cars. So smaller models, but they still need to be secured, and you still need to have the confidence that what you put on a system is actually what's running at the time that you want it to, and that it hasn't been modified, or it hasn't been poisoned in any way. So we know how to do that, actually. There's all those lists of things that you can see there, product security measures, should be implemented, and they actually will provide the secure foundations under which an AI model can run securely, and you can be pretty confident it's not going to be poisoned. And the classic information security controls and the people controls that organizations have to put in to create a secure network anyway. So if we put all of that in place, we're in a much better place when it comes to AI security. But then we can go further. So if we can assure data sets, for example, and say this data set has never been modified, this data set comes from an assured source that I really trust and that has been highly proven and tested, that means that you can prescribe a greater degree of trust in that and do more things, and do more things that are maybe even safety critical. We're involved in some work on a trustable AI bill of materials that allow for the checking of that kind of thing, both in the model weights and the data that it uses, and the inference model and the engine and so on. But there are other things that we can use as well. So Alan Turing wrote a paper in 1949 about the concept of assertions. So assertions are used to check that something is true based on something that you already know. So, for example, I know that 7 + 2 = 9. So we can put assertions into tests against outputs from AI to actually check that they're correct. So if I know that I've got 50 base stations in a local town, and the LLM starts talking about base station number 53, I know that's incorrect, and I can stop it from doing any harm. So that's something that we really need to kind of start to build. And then we need to look at how we communicate trust to other parties. There's a specification in IETF called SCIT that is defined now and that companies can start to use. And then we have to think about minimizing the attack surface. So, for example, many of the attacks that you see against LLMs are what's called multimodal. So I could maybe put a picture of some text of my attack instead of a text input. Well, for a system that only requires text input, why am I allowing it to receive image inputs? So if we can minimize the inputs to models, minimize the models to what they're actually supposed to be doing, and not allow this massive functionality, then we really, really reduce the scope for things to go wrong. So we can build a better future. We can build better AIs that are not going to kill us. And really, I am quite optimistic for the future. But I hope that our human intelligence doesn't degrade to the point that we're entirely reliant on machines. And that's one way that we are heading at the moment. So thank you. I hope that was gave you some things to think about, and I'm happy to take any questions if you want.
Hi, David.
Hello.
Great. My name is Malama. I'm part of the information security over at MTN Zambia. Interesting conversation there, especially moving away from 2G or the legacy systems, if you allow me to put it that way. But I just want to bring it back home. You may know that the acceleration of these higher standards in Africa are very, very low. So I don't know, in your own view, what you think the trade-off would be. Should we leave the old legacy systems behind? Because the digital divide is quite wide in Africa, and we rely mainly on these legacy systems to ensure that we, at least to some level, we enforce connectivity, especially in the rural areas. So this is a very thought-provoking, conversation, in the sense that the time that we're taking to adopt some of these newer systems is obviously not at the pace that the rest of the world is at. So I don't know, in your own opinion, what you think probably Africa should be doing in that area. Thanks, David.
Thanks. That's a great question, actually. And it's something that I've been very worried about. I do some work in Africa, and it's almost like, some of these high technology countries carry on down this route and forget that the rest of the world exists. And then they say, oh, we've moved on now. We don't care about the security for 2G or whatever. We're not going to do any improvement. But there are millions of people that still rely on that. And that does scare me quite a lot, because then the criminals move towards those countries that they see as a low-hanging fruit, using proven criminal business models. So for example, some of the SMS blaster type stuff, and some of the signaling attacks against SS7 will still continue to be available, and maybe have greater technology behind them to make it easier. One thing that I have seen, for example, I always give the example of I think it was Laos and Cambodia, where they sort of kept leapfrogging each other. So they would kind of miss out a generation, and they were competing against each other. And I wonder whether there's this huge opportunity in Africa, because of the huge expanse of geography in terms of lack of connectivity on the satellite side. So as we move between 5G and 6G, the ability for us to infill with satellite will pay great dividends for Africa, I think, and bring connectivity to people who haven't ever been connected. The cost for that is obviously, how do you provide replacement handsets or low cost devices, especially in rural areas. So maybe the conclusion is that we still need to continue to protect 2G, because it will be a very great cost to reach that point, even if you did kind of leapfrog to a satellite-based system. I don't know if that was clear or not.
No, it was great. And I think, just on top of what you said, 2G in Africa and the older legacy systems are here to stay. So I suppose Africa as a whole, we must continue to invest in this type of technology and its security, ensuring that as we connect, the most vulnerable that are in the, as you rightly put it, in the rural areas where this kind of technology is still being used, to make sure that we provide, because people that side equally need connectivity. So I think we must continue investing in security and ensuring that we're securing these technologies, because they're here to stay. I think, in my opinion. Thanks.
Yeah, no, I would agree.
Wonderful. Thank you so much, David. Anybody else would like to ask a question? Don't be shy. Okay, then I hand the microphone back to Don.
Great. David, thanks for joining. Really appreciate it. Great insight, and always respect and value your perspective on the industry. So thanks for joining us.
Thank you, and have a good anniversary event.